1. All right, so now we're going to talk about trig, our SOHCAHTOA. I think if I could redo this year, and I wasn't here for the whole year, right? But if I could redo it, I would not have taught you SOHCAHTOA first. I kind of did that in our first lesson because I knew you knew about it already. But everyone remembers SOHCAHTOA, but they have no idea what it means. So here's what it means. This is the important stuff, sine, cosine, and tangent. SOHCAHTOA is just a thing we made up as math teachers to help you remember it, right? This is fun. This is what it means. This is just to help you remember. So what it means, so helps you remember that sine, which is abbreviated sin, okay, of an angle, that's all that sine means. It means some angle, okay? It's like x, but it's an angle. We call that theta. So sine of some angle, theta, equals the opposite side divided by the hypotenuse, okay? That's all that means. So, S-O-H, sine equals opposite over hypotenuse. That's what it's helping you do, okay? Cosine, when you take the cosine of an angle, okay, it can be the same angle, right? When you take the cosine of an angle, you're going to get the adjacent over the hypotenuse. So when you divide the adjacent side by the hypotenuse side, you get the measure of the cosine of that angle. That's kind of cool. When you take the tangent of an angle, you get the opposite side divided by the adjacent side. So what does that all mean? Well, when you've got a triangle, okay, a right triangle, you've got a couple different sides. You've got the biggest side, which is always called the hypotenuse. We talked about that. And then you've got these two angles. And these are the two angles that we're talking about here. Theta, right? Some angle. If you're talking about this angle, we put theta there because that's the missing angle. That's what we want to find out, right? So that's our angle. That's where we're sitting. That is our reference angle, okay? And they call it reference because it's perspective, right? It's your point of reference, your perspective. So pretend we're sitting here. You are theta. Theta is my Sunday school teacher. Okay? Theta is sitting in a corner of a room, a triangular room. And to theta, when she looks across the room, this thing right here is the opposite wall to where she is. So we call this the opposite side, OPP, O-S-I-T-E. Opposite, OPP for short, opposite. So now we can take the sine of this angle, theta. We can take the sine of theta, okay? And that would be the opposite side over the hypotenuse. So if my opposite is 2 and my hypotenuse is 4, the sine of theta is the opposite over the hypotenuse. So it's going to be equal to the opposite, which is 2, over the hypotenuse, which is 4. Cool. That's fun. If we were to take the adjacent of theta, again, I'm talking about this angle, not this angle. We didn't give this one a name. Theta's not sitting in that corner. If we were to take the cosine of theta, cosine deals with adjacent and hypotenuse. So the adjacent side is going to be the only side we have left, right? This one. This is the wall adjacent to theta that also isn't the hypotenuse. A little confusing. Okay, so this one's opposite of theta because it's across from theta, right? Opposite wall. This is the hypotenuse because it's the biggest wall, okay? And this is the adjacent one because it's right next to her. That's what adjacent means, okay? So this is adjacent. So cosine is going to deal with adjacent over hypotenuse. So let's give this guy a value. How about we give him a value of, I don't know, how about 3? This would totally not work out as a right triangle, by the way. Just making up numbers. So it's going to be adjacent over the hypotenuse. So cosine of theta, whatever theta is going to be the adjacent, which is 3, over the hypotenuse, which is 4. Cool. Tangent, same difference. Tangent's interested in opposite over adjacent, so the tangent of theta, this angle, right? Tangent of theta is going to be the opposite, this guy, over the adjacent, which is this guy. Cool, do we understand that? Awesome. Why is this useful? So if I give you a triangle, like this, okay? And I tell you this angle, 30 degrees. You should be able to figure this out on your own off the top of your head, but, and I give you 2 sides, okay? 2 of these sides. I tell you this guy is 2, and I tell you this guy is 1, and I want you to figure out what this side's going to be. Now you could realize this is a 60-degree angle, and this is a special triangle, so you could figure that out. Or, maybe it's not a special triangle, right? Maybe it's a 35-degree triangle. Now it screws everything up, okay? Now that you've got this, screws everything up. You don't know 35 degrees. That's not a special triangle. So you need to use trig. We're missing one side. We could do Pythagorean theorem. That works too. But we're going to do trig. We've got a couple options. We could do the opposite, because this is the opposite of our angle that we're looking at. Theta's sitting here, okay? And that's the opposite side of her. This is our hypotenuse. We could do 35, what am I thinking about here? The tangent of 35, which would be the opposite over the adjacent. This is the missing side, adjacent. Tangent of our angle, which our angle has a name now, 35 degrees, okay? Equals the opposite, which is 1, over the adjacent, which we don't know. Let's call it A. Now you can solve for A. How do we do that? Well, it's a little messy. We got to get A over here. So we're going to, instead of divide by A, because that's what this means, we're going to multiply by A. So this is multiply by A. And this, we got to do it to both sides because it's an equation. So now we get A times tangent of 35 equals 1. How do we get A by itself? This is where things get weird. So sine, cosine, and tangent have an undo button. It's called the inverse. So instead of writing sine, you're going to write sine inverse. Cool. That's helpful. I'm jumping ahead. Pause, rewind. Tangent of 35. A times tangent of 35. There's a multiplication thing going on here, right? How do we get rid of something that's being multiplied? Divide. We divide. Divide by tangent of 35. As weird as that looks, that's a thing. Do it to both sides. What this means is now we've got A on its own, because tangent of 35 divided by tangent of 35 is just 1, right? Some number after we do tangent to it is going to be the same as some number with tangent to it, right? So it's just A equals 1 over tangent 35. Again, division is just a fraction. Plug that into your calculator and you're going to get what A is. I'm not going to do it because nobody's got time for that. You can do it if you're following along at home. And that's your A value, your adjacent side. That's kind of cool. It's also kind of weird. The key is to know what this means. A lot of you know how to spell it and are able to talk about it and say SOHCAHTOA, but you have no idea what this lets you do. All it's saying is that we've got these special functions, these things that we can put numbers into. A machine, right? Sine, cosine, and tangent are like machines. And when you plug certain numbers into them, you're able to find other numbers. Whenever you set this up, you only want to set up an equation with one variable, right? So we would not set up something like this. Let's say we didn't know what our opposite was. Let's call that O for opposite. Okay? You would not want to set up something like this. The tangent of 35 equals the opposite, which we don't know, over the adjacent, which we don't know. Now we've got two variables. We can't solve for that. It's like doing a science experiment and you're changing all kinds of different things between experiments. You don't know what's causing the difference in your experiment. Too many things up in the air. Try to isolate one variable. Okay? Do we understand that concept? Yes? No? Maybe? Yes? Okay. So in this case, since we don't know either of these, the only thing we've got is hypotenuse. We need to do something that has hypotenuse in it. Which of these guys has hypotenuse in it? These two. We get two options. If we want to find O first, we should use this guy, because it's got an O and an H in it. We know an H, we don't know an O. If we want to find A first, we should use this guy, because it has an A and an H. Do we understand that? Mm-hmm. So let's find O. The way we would do that is we would say the sine of 35, because that has O and H, sine of 35 equals the O, which we don't know, over the H, which we do know. That's an O. To get 2 over here, we got to multiply, so we get 2 times the sine of 35 equals O. Plug that in your calculator, get your value. If you wanted to find A, you'd use cosine, because it has an A and an H in it. So cosine of the same degree, 35, is going to be the adjacent, which is A, we don't know it, over hypotenuse, which is 2. Multiply by 2, we get 2 cosine 35 equals A. Questions on SOHCAHTOA and tangent? Well, I should say SOHCAHTOA and the trig functions. Yes, no, maybe? Is this boring you? Okay. That's that. Why you are here is for the thing I almost showed you. When we take these guys, we're taking an angle and getting out a length, right? These are lengths. If I give you a triangle like this and we want to know the angle, like we don't know what the theta is. We don't know, but we want to know. If I give you a triangle like this, and I say this is a 5, and this is a 4, and this is a 3. The only way to find out what that angle is to use inverse trig. All that means is we're going to do this. The way we write inverse sine is like that. The way we write inverse cosine is like that. Inverse tangent is like that. And we don't say sine -1. It's inverse sine, inverse cosine, inverse tangent. What that allows us to do is to find theta. So normally we'd set up an equation like maybe sine of theta equals, well, it's the opposite, this guy, over the hypotenuse. The thing we're looking for now is this variable. How do we get this guy on its own? Because right now we have the sine of theta. We want to know what theta equals. In order to get rid of sine, you have to use the undo button of sine. This is the undo button of sine. So we're going to sine inverse both sides. When you undo something, it disappears. It turns into 1. 1 times the number is just that number. So it's just theta equals, we sine inverse this whole thing, right? So sine inverse the whole thing. What's the whole thing? 4/5. Plug that in your calculator. Get your angle. Questions?
Can you use law of sines for writing or right triangles or not?
Yes. I don't know how useful that would be here, though.
Yeah.
To multiply that, would you do like, how would you put that in your calculator?
What you would do on most calculators, here's how it works. You've got sine